Bismillahirrahmanirrahim. Assalamualaikum and a very good day to you all. My name is Humaizi. I'm a researcher. I have a capability and skill to find a research gap on various topics. Now I search for research potential on using powder metallurgy using high velocity compaction. Okay, this is a research gap. I found out this is a potential for gap for masters and PhD student, and this slide will show you the tools and equipment and all the machinery that you need to do when you are doing this research on powder metallurgy with high velocity compaction equipment. Okay. Okay, this article is written to help potential student doing research on powder metallurgy on high velocity compaction. It is to help you, this article to help you, to give you some idea that it is possible to you to do research on high velocity compaction, especially when you are in powder metallurgy field. Okay, because this using this equipment name high velocity compaction, not many people have the equipment and tools to do it. Okay, and now I'm presenting you this methodology. Okay, okay, the proof of research gap, only 32 research result in ScienceDirect. Of course, you can find more result in Google Scholar, in Scopus, and anything. Just to get you an overview, uh, the proof that this is a research gap. Okay, there are when you type in ScienceDirect, you type high velocity compaction, and you put the bracket, meaning that give exact result they all, and you focus for 5 years, latest 5 years. These are the result that come out. Okay. Okay, potential contents for chapter 1. All this content is I take from abstract, which is in this, the name of the abstract is the name of the journals. Some of it I present to you in this video. And for the full list, you can purchase the equipment, the list of abstract from Stubia, which is I will give you the link after this. Okay, what people have studied uh, what people have studied on powder metallurgy in relation with high velocity compression. The first one, people want to study about powder compression in high velocity setting. High performance powder metallurgy, iron based alloy fabricated with annealing powder, crack formation, multi particle MPM modeling. This is a software that they use to do modeling on particles upon compaction, compared with high density during powder compaction, transient temperature evolution, and gas mixture detonation method. Regarding about detonation, okay, this is a field that not many people have access to do. Hence, it is also a great potential, because if uh, a research institution have a capability to do live explosion, research, okay, they can do this research on powder metallurgy. This is a gap. Nobody is very few people, very few research institution in the world that have the capability to access with live explosion. Okay, and then they can do high velocity compaction research and also explosive compaction research. Okay, uh, which is I'm not cover in this video. Okay, the problem statement when using, this is some of the problem statement that mentioned in the all the abstracts given. Okay, when I do analysis, the first one is air pressure in press part lead to internal stress. Okay, then the spring back effect, then higher temperature spread in compacted metallic particle, temperature rise during electromagnetic force compaction, and temperature gradient. Okay, what does it mean by uh, air pressure trap? Okay, this particle, when you are pressing this particle, okay, how many hard you press, it always have a air particle inside it. Okay, we using uh, whatever press method that you use, it always have air particle inside it. So this air particle, air pressure will lead to internal stress and make the material not that strong. It's supposed to be strong, but it will not be that strong because air trap inside it. How to make the air go away. This is your research. This is a gap potential for your research. And then the spring back effect. Okay, when you hit and bounce back, hit and bounce back, it will happen because of the mechanical effect. So for phrasing, okay, the thing is, if that material you can press for a long time, the spring back will not happen. But if it suddenly pump like that, especially during explosion, spring back will happen. Okay, how to eliminate spring back? We must use tremendous force. Okay, high velocity compaction is the solution for it. Okay, okay, if you given so high speed, and the mass is very strong, and you can eliminate spring back effect. Okay, high temperature spread in compacted metallic particle and temperature rise during electromagnetic compaction. Of course, and any particle when upon compaction, it, it generate some heat. Okay, and then this is among the what you can study in this field of research. This is among the research objective that I gather from all the abstracts given in all those papers, or that 32 papers. The first one, they are using multi-particle finite element method. This is a popular method mentioned in many journals. Okay, the TT3 multi-particle finite element method. Okay, I suggest people are doing this research, uh, study about this simulation, especially for PhD student. Okay, then study elastic deformation during crack formation, and study entrap air and gas mixture detonation method. Okay, so this is a new method, gas mixture detonation method. Okay, you you blow that you blow it, okay, during gas, and gas, the pressure, the blast wave will press the powder component to become something new. Okay, press particle. Okay, this is a new method developed by I forgot. You can see in the last video in the abstract. There are, or you can type uh, the term gas mixture detonation. You can see how they do their research on it. Okay, meaning that this research facility, must have this capability to do such kind of research, because explosion is dangerous. Okay, however, if you have that facility, proceed. It is a gap. Okay, when you can, if you can do it, you can get your master, you can get your PhD very easily. Okay. Then of course they are studying about entrapped air, how to eliminate the entrapped air, and then elastic deformation during crack formation. Okay, a thing about particle, this particle, okay, when you press, it will become crack. Okay, if that suppose the material, the is thick, material, thin material, okay, no problem, no crack happen. But thicker material, inside of it may have crack. Okay, you don't know unless you cut it, you will see the crack. Okay, because it's not fully formed, this crack will happen. Okay, and then the expected result, this is what the expected result given in all the extracts that I have obtained. The first one is micro hardness, power decrease after annealing, improvement of powder plasticity and compressibility, necessity to accurate model elasticity, including to provide to correct capture force displacement response, then controlling the operating conditions such as packing structure, compaction pressure, and sintering temperature. And they use the modeling, okay, to get some overview. and then low melting point disappear after alloying, increase the temperature, increase the thermal properties of that thing. Okay, this is among the things that you should expect happen during your result. It is a guidance. It's not when you what you find is your finding. At least this gives some guidance how to do that kind of research. Okay. uh Here I listed this research methodology. I have analyzed uh, many things. Okay, particles related properties, methodology, equipment, simulation, and all about other things. This is what you have to do uh, when you are doing this kind of research or other research related to high velocity compaction, and also all other research that related to powder metallurgy. Okay, you will deal with particles related friction, different particle size, grain sample, microstructural, tinted sample, stress wave, and all other among things. You should not miss anything. When you follow my list, here I have helped you to do this list. You should not miss anything. The thing is, you should consult your lecturer, consult your supervisor. If this some of it is not available at your research institution, ignore it. Okay, if this is, let's say, uh, this gravitation based method cannot be done at your research institution, just ignore it. Okay, if it can be done in your research institution, you should do it. Okay, this is provide some guidance to you. Hopefully you will not miss anything. Okay, the fracturing process, pressing process, tensile fracture, fracturing, conduction process, and anything. And then this is related to temperature and heat. There are analysis, heat transfer, gradient, heat conduction, heat flux, sintering, homogeneous temperature, room temperature, sintering temperature, methodology analysis, and many more. And then you are dealing about equipment. This is among the equipment that I noticed they mention in all those 33 journals. Okay, there are laser displacement center, DSC, XRD, furnace, uniaxial die compaction, gas compaction, uh, molded forming, semi-molded forming, and this is all the defects related that I found out in the all the journals. Air trapping defect, microstructural defects, and this is all the sintering related. Because when you are doing this high velocity compaction, especially when you are dealing with explosive and detonation, you will have sintering, especially at the upper surface of this particle. Imagine that particle is thick. When when exposed to explosion, detonation, blast, all the upper side will be sintered, but the lower side will not cannot be sintered that much. Okay, so you can see the differences between two region, upper region and lower region. If you can do it in sandwich structure, meaning up and down, upper and lower have in explosion, um, being exposed with explosion, you can see both region, but it's only only upper side exposed with explosion. Then only upper side will be sintered, lower side will not be sintered. That is, you must notice. Okay, this is especially if you are using explosion. However, when you are using high velocity compaction, it will be compressed only. It will be compressed, not really sintered. It will be compressed, and then you have to take that material to do some uh, sintering process in your sintering lab. Okay, then you can get your result. It should be the particle should be stronger. Okay, when you sintered that material. Okay, and then this is the coefficient. Maybe some of it you can use when you doing some mathematical calculation about it. Okay, this is all the materials that are mentioned in the journal, meaning that these are all the mentioned. But if you are doing your research, you can do material that are not mentioned here. Okay, let's say they are this not mentioned graphene, not mentioned titanium, not mentioned aluminium. Okay, aluminium not mentioned, yes. And meaning that all other materials that are not mentioned is a gap potential, meaning that if you are doing graphene, let's say graphene, doing the research using graphene, let's say, you can be sure you can get master, you can get PhD, because nobody is using graphene in this kind of research. It is proven. Um, they are using alloy powder, alumina, copper, everything. I give example graphene. You can use any kind of material that you want to use. Okay. And list of reference. I only list only 5. They are the full list you can get from the link I will give you in this video link. Okay. So among others, they are introducing novel gravitational based high velocity compaction analysis for pharmaceutical powders, and a link of high velocity compaction, modeling of nonlinear elastic behavior, compaction and solid state sintering of tungsten powder, and experimental and using simulation to study green intensity of titanium powder. Okay, so for those who are interested to get the PDF or the write-up, you can get from Stubia. I will give you the link below. Okay, so thank you very much. I hope this video will give you some insight and some idea to do. Don't worry. Uh, don't worry. Research is actually easy if you know the way. Okay. So thank you very much.